Good evening, dear students. Previously, we have seen the formula revision from the entire subject design of machine elements, and we have not gone into the details, especially for the topic gear and gear trains. So, today we dive into that topic and understand about the terminologies related to gears. Along with that, we also extend the discussion to understand how the gears could be arranged in a different combination so as to get the required output. So, that kind of learning we will see in the topic called gear trains. Gear trains is a topic which mainly deals about the arrangement of gears and how they would be influencing torque or speed values. That is, speed at the output, how it will be influenced. And what are all the different types of gear trains, and how is that we can use them in the real time applications that could be in the transmission box of an automobile, or that could be a gearbox of a lathe machine as well. So these are the areas into which we are more exposed, or we see more of these applications even in our colleges or day to day life as well. So let's begin our discussion. And first part of the gears is to understand the terminology. Let's start our discussion. Belt, gear and chain, these are called as mechanical drives, and mechanical drive is defined as a mechanism which is intended to transmit mechanical power over a certain distance, usually by involving change in speed or in the torque. So these drives are going to transfer the relative motion by influencing the value of speed at the output, or by influencing the value of torque at the output. Okay. Next is the definition of gears. Gears are usually called as toothed wheels or multi-lobe cams which transmit power and relative motion from one shaft to another shaft by using the engagement of teeth. Through the teeth in action, because of action of teeth, the power is being transmitted. Now, let's begin our discussion. The first part is understanding the terminology of the gears. So, in the gears, there are four important circles that we need to understand. Okay. So, this is the smaller one. Adjacent to that, a circle will be there which is slightly bigger than this. Next will be the third circle, which will be still bigger than this one. Let me use the different colors so that you understand. And the last one, that is the circle which has got maximum radius. These are four circles. So all of the circles, remember that they have drawn from the same center. So although in the image you may not find them to be drawn from the same center, but realistically all of them are drawn from the same center. That you need to understand. Okay. So the outer circle is called as addendum circle. Let me do one thing. Let me just copy this image, because as and when we'll be using this image many number of times. So the outer one is called as addendum circle. The second circle is called as pitch circle. And the third one is called as base circle. And the fourth one is called as Dedendum circle. Okay. So now addendum is going to tell us, or it is going to pass through the tip of the teeth. Tip of the teeth, if the circle is passing, that is called as addendum circle. And this is passing through tip of the teeth. Dedendum is exactly opposite of that, passing through root of the teeth. So let me just copy this sentence. So instead of tip, I should be replacing that with root. Root of teeth. Okay. Next is pitch circle. Pitch circle generally corresponds to rolling action. Rolling action. And this circle is very, very important, as when we do the force analysis or when we measure the important parameters. Okay. Important parameters are measured. So those important parameters we will be seeing in few more minutes. And this is also corresponding, or when we do the force analysis, even then also this circle is used. Base circle is referring to generation of involute profile. This is a circle from which involute profile is generated. Okay. So these are the specialities of the four circles which are there in the gear. Now, let's try to understand the other parameters associated with it. Okay. So the heading would be important circles of a gear. Okay. So remember that pitch circle is the only one where you find more discussion. This will be more frequently used circle, or this term will be more frequently used. Other than that, if you ask, addendum and base circle are the important ones. Now let's try to understand the terminology related to each of these, for each of the gears. Let me go to the next slide. Yeah. So first is pinion and the gear. Okay. All right. So now, before we get started with the next slide, let me write here a few more terms. This is a smaller circle, and this could be a bigger circle. So if the gears are in mesh, if the gears are in mesh, they could be represented by pitch circles. Gears in mesh can be represented by pitch circles. Pitch circles touching each other. Okay. So the smaller one is called as pinion, and the bigger one is called as gear. Pinion is generally preferred as input element or input link, and gear is generally preferred as output element or output link. Reason is that pinion is smaller in size, so the inertia of pinion will be less. That is why the pinion is preferred as input element. To the pinion we attach, or pinion is generally mounted on the electric motor, that's an prime mover or an input device, and gear is mounted where the load is being applied, or it is mounted to the machine. Machine is also one form of a load, because that machine could be doing some operation, it could be cutting operation, it could be drilling operation, etc. So operation is associated with the load. Now let's try to understand each of these. So as I mentioned, pinion and the gear, pinion is the smaller one and gear is the bigger one, and pinion is preferred as driver element and gear will be driven. This is input element, or you could say this as driver element. Both concludes the same meaning. Gear is referred as output element or driven element. Don't get confused. Driven or the output element. Okay. Or you may contradict my question, that is in the bicycle, especially at the pedal side, you will find the bigger sprocket, and at the tire side, that is at the back tire or rear tire, you will find the sprocket which is of smaller size. So bicycle, it's a manually powered machine, but if you deal with an electric powered machine, then you are supposed to take pinion as an input element and gear as an output element. That's where you are supposed to uh, take a protocol. Okay. Next is velocity ratio. This velocity ratio helps us to predict about how many times, by what factor we are able to increase the speed of the output wheel or decrease the speed of the output wheel, or you could replace the speed with torque as well, because torque and speed are inversely proportional to each other. This is from the power equation. Okay. So if I write the power equation, which is P is equal to 2 pi nt by 60 or 60,000 if this is in watts. So from here you understand that torque and speed have got inverse relationship. So when you are trying to increase the speed, the torque definitely drops, or when you are trying to increase the torque, the speed is definitely going to drop. Okay. Next is velocity ratio. After that, velocity ratio is expressed as angular speed of the driving gear to angular speed of the driven gear. So velocity ratio is designated by letter lambda. So lambda, or this is equal to VR. This is also written as omega of input divided by omega of output. Okay. And transmission ratio is expressed as velocity of first driving gear to the angular velocity of last driving gear in the gear train. So remember that. Yeah, let me just go back to we'll go back to the previous slide, because there I missed to add one point. So pinion and gear, this is called as pinion and gear in mesh. Pinion and gear in mesh is also, let me write it over here, pinion and gear in mesh. So this pinion and gear in mesh is also referred as gear set. This is called as gear set. Okay. Now, velocity ratio is specific. He's very specific. It is dealing with two elements. That could be called as gear set. But if you ask me about the transmission ratio, then for transmission ratio, it is more than 2 gears. It's more than 2 gears. Okay. It could be 3. 3 means it has to, you cannot call that as a gear set. Instead, you have to call it as a gear train. If it is 4, 5, 6, whatever the count be, it is still called as gear train. If it is 2, then I have to stick with the keyword called as gear set. Now next is pitch surface. Pitch surface is nothing but the surface corresponding to pitch circle, or the surface that is corresponding to pure rolling action. Those are called as pitch surfaces, or I could say corresponding to pitch circle. Okay. Now next term is pitch circle. Pitch circle is basically, as I told you in the previous slide, pitch circle is corresponding to rolling action, and it is an important parameters are measured on the pitch circle. Remember that. Okay. And the second circle within the second circle immediately after the red color one is the pitch circle. Okay. So it's an imaginary circle which rolls without slipping with the pitch circle of meeting gear. Okay. So two gears, if they are in mesh, or if their teeth are in mesh with each other, they could be simply represented by two pitch circles touching each other. That's all. That's a very simple or schematic representation of gears in mesh. Pitch circle of pair of meeting gears, they are tangent to each other. Remember that. The pitch circles will be tangent to each other. They will never intersect. they will be touching each other. They will be tangential to each other. That's the point what you are supposed to remember. The pitch circle diameter is called as diameter of pitch circle, and the size of the gear is usually specified by the pitch circle. And this is also referred as pitch diameter, and pitch diameter is denoted by simple letter D. Simple letter D. So gear size is specified by the pitch circle diameter only. That you are supposed to remember. Next is pitch point. Pitch point is a point that is passing through line of center of two gears at which two pitch circles of meeting gears are tangent to each other. Now, let me just redraw. This is the simple representation of gears in mesh. So what happens is, this red color is referred as pitch point, and this is center of pinion and center of gear. So if I draw a line joining center, this is called line joining centers. Line joining centers. So line joining centers, that is pitch point is a point on line joining centers at which two pitch circles are tangent to each other. So basically where the point where two pitch circles touch each other, okay, is called as pitch point. This is P, and P here is called as pitch point. Next is topland. Topland is the surface of the tooth, surface of gear tooth. Let me explain that to you. So let me copy this diagram, as I'll be saving the time. So this, in the same diagram, what I'll do is I will try to draw a three-dimensional view of the teeth only. So this is a three-dimensional view of the teeth. Okay. So remember here, this top surface, this surface of the teeth is called as topland. This is called as topland. Now adjacent to this teeth, there will be another teeth that would be mounted. These two teeth will be separated. Let me just remove the circles out of here. So adjacent to this teeth, there would be another teeth that is being cut. So please don't mind the accuracy of the drawing. The intent is to understand. Otherwise, I could have taken the image, but I want you to develop the imagination. Okay, I want you to understand, or try to understand, try to develop this by your own brain. Okay. So now this is called as bottom land. And yeah, here the bottom land, let's see the definition. The top land is the surface on the top of gear tooth, and bottom land is the surface of gear between the flanks of adjacent teeth. What is a flank? Okay, now you can intercept, or you can divide the teeth into two parts, not equal but two parts. Okay, you can divide the teeth into two parts. The top part of the teeth is called as face. This is called as face. Sorry, this is called as face. And the bottom part, which I'm shading in red color, This is called as flank. Okay. So, and the face and flank, how they are divided, if you ask me, then, dear students, it's quite simple. It's the pitch circle which is going to be a border between these two parameters. Based on the pitch circle, based on the pitch circle location, you could segregate this as two different parameters. Let me give you one more thing, as we have been talking about face and flank. So this part is called, or this dimension is called as face width. This is called as face width. Okay. And this is a very important dimension, especially if you are trying to design the gear tooth. Or sorry, if you are trying to design the gear, this is especially a very, very important dimension. All right. So these were few parameters, and let's go to next slide and try to understand the other parameters of the gear tooth as well. Let me copy these circles. So now the first part is involute. Involute is the, basically you might have studied cycloid and involute. So let me give you that simple definition, or let me help you with a simple theory. Okay, there is a circle and there is a straight line, or a horizontal surface or flat surface. Okay, so now one is that you are fixing the line, and this circle is being rolled over it. The circle is being rolled over it like this. Okay, you are rolling the circle like this. So when you roll the circle, then the circle is going to take a new position, and the point will be also moving around the circumference, and the path that has been traced by the point, is called as cycloid. Now for involute, what you do is you take the same circle. Instead of fixing the straight line, you fix the circle, and on this circle you try to roll or rotate the line, or you try to move the line like this. Okay, the line, when it moves, it's not going to be fixed at one point. Along with rotation, it keeps translating to different positions. And if you try to understand the locus of any point on that line, then you are able to see the development of involute profile. Okay, so the logic is very simple. You are taking a circle, you are taking a line. First is that you fix the circle and you move the line, and second is that you move the line and fix the circle. So you are going to get involute. Okay, and you have already done that as in practice, especially when you fly the kites. So you will be unwounding the thread from the spool, or you would be wounding the thread on the spool. So the locus of any point on the thread will give you an involute. Quite simple. It's not something you have to look for it, but it is what you do in your daily life. Now moving to next one. Involute is a curve traced by a point on a line as a line rolls without slipping on a circle. Next is the base circle. It is an imaginary circle about which an involute profile is being generated. So these are the circles, especially the third circle about which the involute profile is generated. So from this circle, you are generating involute profile. And what about the remaining half? The remaining half will be straight, will be a straight line. Okay. So the bottom half is a straight line. You can call it as non-involute portion. Non-involute portion. The bottom half is called as non-involute portion. And the remaining red color one, is called as involute portion or involute profile. Okay. So remember these things. Now let's get back. Addendum circle is an imaginary circle that borders the top of the gear teeth in the cross section. So we have seen this already. This is not new for us now. Next is addendum. Addendum is actually radial distance. Okay, this is the pitch circle. So from this point up till the tip of the teeth is called as addendum. From this point up till the tip of the teeth is called as addendum. Next is, remember that as you are segregating the sideways of teeth on the basis of pitch circle, that is, you are naming them as face and flank. In the previous slide, I have done that. Okay. The same thing I am doing in the front view. I am calling this as addendum, that is radial height. Radial height above pitch circle is called addendum. And up till the root portion is dedendum. This is called as dedendum. Okay. Same way if I project it over here, this would be dedendum. So here, just because I am using the free sketch, so you may find that addendum is smaller and dedendum is greater. That's true. That's absolutely true. Even in the reality also, that will be there. Okay. Addendum is greater than dedendum. Remember that. Okay. Now, next parameter is dedendum circle. Dedendum circle is an imaginary circle that borders at the bottom spaces between the teeth in cross section. It is called as root circle. Basically, that it is passing through the root. And dedendum is the radial distance between the pitch circle and the dedendum circles. Dedendum indicates the depth of the tooth below the pitch circle. Next is clearance. Clearance is basically defined when the two gears are in mesh. When the two gears are in mesh, only after that you could define the clearance. So let's say this is one of the gear and let me draw another gear. Okay, so I am taking only single teeth from the other gear. So the gap between the teeth or tip of the teeth and the root is called as clearance. Is called as clearance. This gap is called as clearance. Okay. So remember that this clearance is also giving you a provision for the lubricant to flow between the interacting surfaces. That's what the teeth would be doing. Sorry, that's what the clearance would be doing. Okay. Next is face and flank of the teeth. I have mentioned that the surface of the gear tooth above pitch circle, between the pitch circle and the addendum, is called as face. This is called as face. And next is the surface of the gear tooth between the pitch cylinder and the root cylinder is called as flank. The green color is to indicate flank. Please remember these two parameters as they will be deciding the interference, or when we talk about interference, these two parameters will be playing a very important role. Very important role. By that, what I mean to say is they would be more frequently used, and you should not get confused when you try to understand the phenomena of interference. Okay. So these were the parameters, and let's continue our discussion. So face width, I have told you that already. Let me mark it over here. This is called as face width. This dimension, you call it as face width. And the fillet, the radius that connects the root circle of the profile to the tooth is called as fillet radius. The radius that connects the root of the profile to the tooth. So sometimes what happens is that to the involute profile, you are going to connect by using a different fillet radius or different radius. So this is where up till where the involute profile is being generated, and from here up till the root of teeth, you will be connecting that with a different circle, or it could be a straight line. So this is called as, or the bottom one is called as fillet radius. Okay, and this is called as root. From the root up till involute. Okay, you could see the rhyming happening over here. Root to involute. Okay, it is the fillet radius that which connects. Next is tooth space, or sorry, circular tooth thickness. The length of the arc on pitch circle subtending on single gear is called as circular tooth thickness. Okay, so let me go to the bottom of the page wherein I can describe all these parameters. This is the gear tooth. Two gear teeth I have taken. So let's say this would be the pitch circle. This portion is called as, along the pitch circle, remember that this is called as tooth thickness, and this portion is called as tooth space, that is distance between the adjacent teeth is called as tooth space. So circular tooth thickness, it is the length of an arc on the pitch circle subtending on a single gear tooth, is called as circular tooth thickness. Theoretically, circular tooth thickness is half of the circular pitch. Circular pitch is actually defined as distance between the two teeth, okay, at the same point. So this dimension along the pitch circle is called as circular pitch. There is a mathematical equation for that. We will write in few more minutes. Okay. So next is the width of space between the adjacent teeth measured along the pitch circle is called as tooth space. Theoretically, tooth space is equal to tooth thickness, which is half of the circular pitch. So remember that we could derive, or we could write a formula for this. A simple mathematical equation. Now, tooth space or else circular pitch will write it later. Okay. Next is working depth. Working depth is the depth of engagement of two teeth, and this is summation of addendums. So when the two teeth are in action, that is called as working depth. So I have taken this diagram and let me explain, or let me highlight this for you. This is the pitch circle of the red color gear, and let me draw the pitch circle of black color gear. So this is the addendum. Okay, let me use a different color. This is addendum of the red color gear, and this is addendum. This height is addendum of black color gear. So this is addendum, and this would be also addendum. You could say this as pinion, and you could say this as the bigger one, that is gear. So working depth is basically summation of addendums. It is the summation of addendums. So working depth formula, I could write that as addendum of pinion plus addendum of gear. Okay. And if addendum is combined with the clearance, we get hole depth. We get total depth or hole depth. That is working depth plus clearance is equal to total depth. Or the other formula for this is nothing but the height of the gear tooth, entire height of the gear tooth. This height of the gear tooth is called as total depth. Okay. So the other way to write this is addendum of pinion plus addendum or dedendum of pinion only. Dedendum of pinion. So as I mentioned that previously, dedendum will be greater than addendum. I mentioned that in the previous slide. Let me go that and show it to you once again. So where I concluded that dedendum will always be greater. Yeah. Here I said, okay, let me just reverse it. I was saying dedendum to be greater. So although I have written it incorrectly, but I was saying that dedendum is greater. So dedendum is greater than addendum. Remember that. Okay. All right. Let me go to the next slide. Yeah. Center distance is the distance between the gear tooth, that is between the gears which are in mesh. So when the gears are in mesh, this will be called as center distance. CD stands for center distance. Okay. Next is pressure angle, line of action, arc of contact and arc of approach. I will, yeah, contact ratio. So I'll do one thing. I'll just complete the contact ratio and I'll discuss this pressure angle, line of action, arc of approach and arc of recess in the next slide because they involve a lot of drawing actually. Okay, so first let me take up contact ratio and circular pitch and diametrical pitch and module. Let's deal with the simple ones and then we'll come back to the complicated ones. So contact ratio is referring to number of teeth that are simultaneously engaged is called contact ratio. If there are two pairs of teeth in contact at all the time, then the contact ratio is 2. That means two teeth fully in contact with each other. So as the gear rotates, smooth and continuous transfer of power from one pair of meshing teeth is achieved. And when the contact ratio of first pair continues, when the contact of first pair continues until the following pair is has established the contact. So first pair of teeth will come in contact until and unless they are going to separate from each other. When the separation has started, the next teeth after that, the next consecutive teeth after that will get set into the action. It's like kabaddi players. Okay. One player he will try to enter the other side and then immediately when he jumps or when he crosses the line and then come back to his own court, then he has to tap the other friend, so other friend will get into action. That's how it is. Okay, you could say that all the players are around the circumference and they are playing kabaddi with each other. Okay, so that's how it is. That logic could be the logic or simplified logic. Okay, some overlapping is essential for this purpose and therefore the contact ratio is always more than 1. Other things being the greater the contact ratio, smoother action of gears, and contact ratio for smooth transfer of motion is usually taken as 1.2, and for industrial and power transmission applications the contact ratio is somewhere between 1.4 to 1.7. So these are some of the values adopted for the industrial applications. Yeah. Let's see the circular pitch and we'll get back to pressure angle and diametrical pitch, pressure angle and line of action as well in few more minutes. So circular pitch is the distance measured along the pitch circle between the two similar points along the teeth. Okay, circular pitch is given by P subscript C. Okay, and diametrical pitch, this is specially used in FPS system. This is number of teeth per inch of diameter, that is P subscript D is equal to number, that is T by D, that is T is number of teeth and D is pitch circle diameter. Module is referred as reciprocal of diametrical pitch, and circular pitch PC is given by pi times of module or pi into D divided by T. So this is basically tells that in a given circumference how many teeth are being placed, something of that type. In a given circumference, how many number of teeth you are finding it. Okay. Module also will convey you about the thickness of teeth. Okay, it will give you the indication about thickness of teeth. Thickness of tooth, I should say, because we are dealing with single entity. Okay, so module is inversely proportional to teeth. So when it is inversely proportional, more the module, then more thicker the teeth and less number of teeth. Okay, more the module, more thicker the teeth and less number of teeth. Lesser the module, more number of teeth and more thinner the teeth. More thinner the teeth. Okay. So now we'll talk about pressure angle, and we'll talk about arc of contact, line of action and arc of recess. So if you go back to the important circles of the gear, we have drawn root circle, we have drawn base circle and addendum as well. But now we only consider base and pitch circles. We only consider base and pitch circles. Okay. What about other two circles? We are not going to consider them because the entire force analysis, for doing the force analysis, we only need base and pitch circles. So this is the smaller one. Let's call it as pinion. And this is the bigger one. Let's call it as gear. Okay. So pitch circles will be touching each other. The pitch circles will be touching each other. Now let me do one thing. Let me just highlight these two circles with a different color so that you have the proper distinction. Okay. This is the center of pinion, center of rotation of pinion, and this is center of rotation of gear. And these two circles, wherever they touch, that is called as pitch point. So now what I am supposed to do is I need to draw a line that is that is a tangent to base circle, that is a tangent to base circle as well as tangent to base circle of pinion and gear, and it has to pass through point P, and it has to pass through point P. Okay, so although it is a rough sketch, I have to reorient this line, somewhat change in its orientation so that I can fix it properly. Okay, let me just modify the size of the circle. Maybe that could help. Yeah. So this is, if you try to understand, this is a line or this is a thread which is getting transferred from red color spool to green color spool. This is getting transferred from one spool to another spool. Okay. So if I take this line and if I make it horizontal, okay, if I take this line, let me draw one thing, let me do one thing. Let's say this is some line, rough line. Okay. So if I take this line, this is like a thread which is getting winded around, which is getting wounded around this circle, like a transfer of thread, what we specially do in the kites season. Okay. So more or less, like you could say, generation of an involute. So what happens is here, you have to remember the logic of kabaddi. Okay. So this teeth will be in action. The teeth of pinion will be in action with the teeth of gear. Okay. They will be pushing each other along this line, along this line. Okay. So this is called as, or from this line, or if I draw a vertical, or this is the line joining centers. Okay. This line or common tangent, what we have drawn, is called as line of action. This is called as line of action. Let me extend this. This is called as line of action. And now if I draw a vertical line or line perpendicular to line joining centers. Line perpendicular to line joining centers. Okay. This is line joining centers. Okay. Now what I do is I draw another line which is perpendicular to this line joining centers. Okay. And if I rotate this by 90 degrees, it becomes vertical. And this will be line joining centers. And this angle between the line of action and line joining centers, normal to line joining centers, this is called as pressure angle. This is called as pressure angle. Very, very important. Very important. Dear students, now this line will be intercepted into two halves. Okay. And first half is called as path of approach or path of engagement. Okay. So let's say pinion is rotating in clockwise and which will drive the gear in anti-clockwise. And the second half will be called as disengagement. Path of disengagement or path of recess. Same thing if we try to express in terms of arc, then it becomes along the same line. If we try to draw an arc, it becomes arc of engagement and arc of recess. Okay. So this is about the important parameters, and together the whole entire line is called as line of action. And if this is expressed, or if it is made in the form of arc, then this is called as arc of contact, or this is also called as line of action also, or line of contact, line of transmission. So there are many numbers that could be given to it. There are many names which could be given to it. Okay, many names that could be given to it. All right, so this was about the terminology of gears. And next is we talk about the most important part, that would be gear trains. Okay, that would be gear trains. So if you go back to the previous class, we talked about only the classification of gear trains. So first is, let me give that classification to you, and after that we'll try to understand each of the gears in a more detailed way. So first is simple gear train. Second is compound gear train. Third is reverted gear train. And fourth is epicyclic gear train. Okay. So for today, we'll try to only learn simple gear train and compound and reverted gear train. Epicyclic is little complex. So we'll take up that in the next session. Reason is that for simple reverted compound, it's easy to write, but epicyclic requires a bit more analysis. Okay. So first is simple gear train. Let's begin our discussion with simple gear train. Simple gear train is going to consist of more than 2 gears. You could use 3, 4 or 5 gears, no problem in that. So this would be bigger gear. This is another smaller gear. And let me add one more gear. So all these gears are in mesh. So this is gear number 1, gear number 2, gear number 3 and gear number 4. So whenever you are trying to write train value or velocity ratio, that is train value, let me write the definition for that. Train value is given by, that is speed of output, which is also called as driven, divided by speed of input, that is called as driver, and this is equated with product of teeth values on, remember driver was in the denominator, here driver goes in the numerator, and the same thing, product of teeth value on driven member, on driven element. This was driver element. So now you could be using the combination of two elements, that is 1 and 2, next is 2 and 3 and 3 and 4. That would be the combination you are going to use. So output here is 4 and input is 1. So omega 4 divided by omega 1 is equal to, now here I need to write plus or minus sign, because plus or minus sign is for same sense of rotation, plus is for same sense of rotation, that is internal gearing, that happens in internal gearing, and minus sign is for opposite sense of rotation. This happens in external gearing. This happens in external gearing. So what happens is, first we take the combination of 1 and 2. We replace this with 1 and 2 as in gear set. That is omega 1 is input and 2 is the output. And now 2 becomes, we take the combination of 2 and 3. Take the combination of 2 and 3. 2 becomes the input and 3 becomes the output. Next we take the combination of 3. 3 becomes the input and 4 becomes the output. Now what we do is, we replace the speeds with teeth values. That is equal to omega 2 by omega 1 will be replaced by T1 by T2. Minus sign because it is external gearing. As 1 rotates in clockwise, 2 rotates in anti-clockwise. As 2 rotates in anti-clockwise, 3 rotates in clock. If 3 rotates in clock, 4 rotates in anti-clock. So between 2 and 3 it is external gearing. Once again it will be replaced with T2 by T3. So 2 goes in the numerator and 3 comes in the denominator. Same way for 4 and 3 it will be negative sign, and omega 3 is in denominator, T3 will be in numerator and T4 will be in denominator. So the end result what you get over here is omega 4 by omega 1 is equal to minus T1 by T4. This is called as train value. Okay. So this is what we have done for simple gear train. Okay. So like that we have compound gear train, reverted gear train as well as epicyclic. So let's move on to compound gear train. So I'll use the same diagram, but in the compound gear train, what you find is, okay, let me go to next slide. So this could be gear number 3. Gear number 3, I could bring it over here, mounted on the shaft of number 2 only, mounted on the same shaft of number 2, and gear 4 will be brought closer to this. Sorry, gear 4 will be in mesh with 3. Gear 4 will be in mesh with 3. This is how it would be. And if you try to analyze this in a 3-dimensional way, this was gear number 1. Okay, and this is the shaft of gear 1. And gear 1 is in mesh with 2. 2 is the bigger gear. Okay, and in front of 2 I will draw gear number 3, which is smaller one. Okay, so please try to understand, this is a rough sketch. And gear number 3 is in mesh with 4. So gear number 4 is supposed to be bigger. This was gear 3, and gear 4 is supposed to be somewhere here. And this is the shaft of gear number 4. Okay, this is 1, this would be 2, this would be 3, and this would be 4. So this is how an rough sketch would look like. Now once again you can try to write the train value. Train value, the same formula. Let me copy that. Let me copy that. The same formula will be there. So now we will take the combination of gear set, that is omega 4 will be output and omega 1 will be input. So now we take the combination of 1 and 2. So omega 2 by omega 1, 1 is the input and 2 is the output. They are externally geared negative sign, so or else negative sign, we'll add it later. Next is, you could say 2 is the output and 2 is the input and 3 is the output. So 2 is taken in the denominator and 3 is taken in the numerator. Same way 3 becomes the input and 4 is the output. Now do remember one thing over here, that is 2 and 3 are mounted on the same shaft. So it's their value will be same. Their speeds will be same. So they will cancel out each other. They will cancel out each other as 2 and 3 are mounted on the same shaft. That's where you call compound gear. Gear 2 and 3 are compounded. They will have same speeds. Okay. So what happens to this is omega 4 by omega 1 is equal to, this will be replaced with minus T1 by T2, and this would be replaced with minus T3 by T4. This is the final expression for train value. This is the final expression for train value. Let me take up the reverted gear train as well. In the reverted gear train, there is one beautiful thing. I mean, if you try to understand how quickly we can save our efforts in the learning. So in the reverted gear train, what happens is gear number 4 will be concentric with 1, but they will not be compounded. It is 2 and 3 which is compounded, but gear 4 is not at all compounded. Gear 4 will be in mesh with 3. Remember that. Gear 4 will be in mesh with 3, but gear 4 will be coaxial with 1. Same equation. Okay, analysis is same. Gear 4 is coaxial with gear 1. So if you are asking me what happens in the three-dimensional view, let me show that. Let me copy this diagram and then let me show you how simple it is. Okay. So what we do is gear 4 shaft, gear 4 will be disengaged from here, and this was the shaft of gear 1. I am reducing the length of gear shaft, shaft of gear number 1, such that I can accommodate gear 4. But remember one thing. Gear 4 and gear 1 shaft is not single. They are split. There is a discontinuity in the shaft. On this side, you could find gear 4 is in mesh. Okay. Gear 4 is in mesh. This is the gear 4 and this is the let me redraw it once again. So this is the shaft of gear 4. The shaft will be along the same axis. But 2 and 3 are compounded. If you ask me what about the result, the analysis is same. It is just that you are shifting the position of number 4. Okay. So these were a few concepts from the gears chapter, that involved terminology of gears and elementary analysis of gear trains. So we have taken compound gear train, and we have also taken reverted gate drive. So different, there is only a difference in arrangement for these two. Okay. But otherwise in mathematics, you are not finding any variation. Okay. So if you find the session now, so let's conclude the session. If you find the session as more helpful in your exam preparation, so stay tuned with our channel, hit the subscribe button, and share it with your friends who are in preparation phase. Thank you, everyone, and good night.